Okay, welcome everyone back our lesson. So today's math lesson is very kind easy, matrix computation. This is a lesson, a part of introduction to the quantum computing and the programming. Yeah, so today is kind of very easy. So we look how it's easy. Okay, I'm not sure because this is kind of a lot of math. Yeah. Okay, so what is matrix computation? Matrix computation that's mean how you multiply. Yeah, how you multiply, how you plus, and how you subtract. That's all. Yeah. Okay. For example, over here we have two vector, or we have one vector. We have we have one vector A. Yeah, one vector A. And this vector A includes a matrix. Yeah, matrix. And this matrix have two dimensions. And the first dimension they have m rows. And this n the columns. Yeah. So each column, this vector A denote a set of all the m multiply n the matrix with complex entries. So if you see this kind of version, we have two dimensions, right? So this kind of this is kind of rows. Yeah, this kind of rows. This rows, and this is column. Yes, this is column. So when we present in the one vector, we cannot do in the the two dimensions. So and after we can shorten it. Yeah, over here we shorten. Okay, shorten the rows to the one the A1, right? Or we can shorten by column. Something you shorten this column, you can shorten this one, right? Have a two way. You can shorten by rows, or you can shorten by column. So over here, if you say about the shorten by the rows, we can say A have m rows vector or n column vectors. Yeah. So that is easy. Okay. This is kind of basic. Yeah. Two dimension. We can shorten it by the column or by rows. Okay. Now we have the A vector with m rows vector and n column vectors. Yeah. So yeah, this one is we have this is a rows, yeah, and this is column. And after we can represent, this is kind of shortened part of the column, the rows. We can see this will have n the column, right? One row and n column. And if we represent by the the rows, so it have only one column but n rows. Yeah. So for example, over here is one of example. You have a vector. This is a three. These are three rows and four columns, right? 1, 2, 3. 1, 2, 3, 4. So 3 rows and 4 columns. So you can shorten it by the the rows. Like we have 1 rows and the 4 columns. So 1 rows A1, yeah. Or we have 3 rows and 1 column. So if we select by rows, so we can see this A1. This kind of value, right? So you can see, yeah. Is similar. We select by rows, and if we select column, you see this one A1. So you can select the first column, right? The first column, right? Yeah, the first column. So that is how we can shorten it and make sure we can represent our vector in the two-way columns or rows. Yeah. Okay, so now we have some concept. We have a square matrix. Square matrix, that means we have the rows number of rows equal to number of column. For example, we have a 2, 2, right? 1, 2, something. This one is we have a 2, 2. So this is a square. Number of the column equal to number of rows, okay? So that's square. We have a 0 matrix. That means this kind of everything is 0, yeah. Okay, everything is 0. And what about the identity, the matrix? Identity matrix, that means we have the value for the matrix element equal to 1 if the two elements equal to index together. Something like this. Yeah, so you will see this is the first column and the first row, right? So it's equal to 1. And see, sorry. Yeah, so this one is 2. This is 2, 2. So this is equal the value. Yeah, this one. So it's equal to 1. What's about the diagonal? Yeah. Diagonal, yeah, diagonal, the matrix, what it mean? So actually it's a different. This one from this one is a value for 1. So but this one can be about the 2, yeah, 4, something like that. But in the in this the z direction, we need to have we have a value, but the other place on the 0, okay, on the 0. It's different from this one. This one must be identity. This one we on 1, okay? Only one value. Yeah, that is how different. This is some related term. It's kind of easy. Okay? Yeah. So I hope everyone got it. Okay. Now we have to the matrix. So how we can plus or add the two. Actually now, yeah, we have two matrices A and B. So if we plus two vectors. It's a simple, okay? Simple. You only need to plus this one and this one, okay? Same position. For example, this one is 1, 1. So you need to plus with the 1, 1 position in the vector B. Yeah, you can see, right? 1, 1. So you similar. You need to make sure that this kind of value is same, okay? Same position. A11, A12 plus with B12. But this one, if you see the 2, 1, it's wrong, okay? Make sure this one is the same. Yeah. So actually, yeah, if you can add, actually it's for example, this one when we add this one, yeah. Sorry, it's add this one, so you can see, yeah, the same value, right? Same value, right? Yeah. About the scalar, the multiplication, that means multi with one the the constant. So C. So this one actually you only need to multiply with x of element, C multiply A11, yeah, something you see. That's all. Yeah, very easy. Yeah. And about the matrix multiplication, this part is one of the most difficult part, but I will tell you how to do very quickly. Okay, we have the vector A and multiply with vector B, and if you see this kind of dimension M, N, and the NP, this one is very important. You need to remember. If you want to multiply two vectors, you need to at least the column, the dimension need to match each other. If you see the column, the number of column in the first vector need to match number of rows in the next vector, okay? You will see this is called number of column, right? Equal to number of rows in the second vector. If you do not match this kind of condition, you cannot multiply two vectors, okay? That is very important part. And when we have the A, yeah, with A and multiply B, so we can see the total value. So we have M. We will have M multiply P, and we will remove one N. Okay. That is the value for match. Yeah, to make sure we can competitive. Yeah, yeah, compatible. Yeah, compatible multiplication. Yeah. And when you multiply, so yeah, it's similar. You multiply x value, okay? X value. So you can multiply x value for the first part. Yeah, first part. Yeah, you can see. Yeah, you can multiply x1, and you can go to next. Yeah. So this kind of similar like the previous one. Yeah. So. And the other thing, we have inner products in the the real number. So yep, you see over here we do not have the imaginary part. Imaginary part we have I. Okay, over here we only have the real number. So this is kind of how we multiply the matrix in the real number. So it's similar. You multiply. Yeah. Okay, so this part is. Yeah, I think this is makes me like. Yeah, this one we multiply this one. Yeah, multiply. Okay, so make sure it's correct. For example, we A1 B1, A1 B1 and A2 B2. Yeah, AB2 and AN BN. Yeah, sorry. Yeah, to make sure we do correct. The last time maybe I do incorrect. Yeah. For example, this one we have two vectors, right? So two vectors, so we can transfer to the the column, the vector A the column, and the vector B the rows. So after that we can multiply this one, right? Yeah, this one, and we have this one and this one. Yeah. So you can see this total value. After we multiply the h1, you can transfer to the rows and column, yeah, and multiply together this one, and this one, and multiply each other equal to this value. Okay. And similar, we can have we have a 4 value, right? So we can multiply with this guy the value, yeah. And associative, associative actually doesn't matter how you compute. A, B, C. So you do AB first and C later. It's equal to you do a BC first and A later. So that doesn't matter. The computing the process, the order is not important. Yeah. So it's similar. Like we have a different computing structure. You can do this first and this first, or this later. It doesn't matter. Have a same value. Okay. It's similar like previous lesson. Okay. So over here we already learned about the matrix. Yes, matrix computation. Yeah, matrix computation, and how we can multiply the two vector A and multiply the two vector B in the kind of use kind of matrix. Yeah, I hope this part is kind of I think the easiest part in the the quantum computing, and maybe all of you already learned in the high school or maybe in the university. Yeah, even not, so don't worry. You can follow this part and try to do some example, and you can got it. Yeah. Okay. Thank you, everyone.